Thanks for joining us. We'll make a start. So thank you for joining us on this WebEx, the 3 ways AI will change healthcare by 2030. This has been a joint effort between Kubrick and Technology, who are both working on future digital skills in healthcare. As I said a little bit earlier, we're going to kick off using Mentimeter and be using it throughout the actual event itself. We're going to ask you to go to www.menti.com. But before we do, we'll be collecting questions as we go through the event. If you can use the Q&A function on the actual tool itself, then we'll be collecting questions there and do a couple after each speaker, and then we'll do a panel session at the end. We're also using a hashtag here. So today's hashtag is Data Saves Lives. For those of you that don't know about Data Saves Lives, it is a movement that started as part of Connected Health Cities in the north of England and has now been adopted by Europe. And it is all about providing evidence for healthcare, lives being saved and improved using data. The two Twitter handles are @TechnologyHealth and @Kubrick Group. So if you want to actually share some of your thoughts as well on Twitter, then please use that hashtag and the Twitter handles. So just to make sure that everyone's on Menti and is able to use it, we're going to do a quick poll to find out where you're from. So if you go to menti.com and use the code 66134622, then we're just going to take a quick poll to work out where everyone's from. Scotland is definitely represented. So we've got Scotland, we've got England, Wales. This is good. We definitely have the nations represented. Wonderful. We had some people last week from GCC and also from Australia. And I know, John, you're in Australia, middle of the night there, so very brave people joining last time. That's good. So we've got about 63% of people from England. We've got some from Wales and Scotland as well. So thank you very much for joining us. And obviously Menti is indeed working. On to the next question. So this is the question before we actually start this webinar. And really, it's just to take temperature check. We want to know if you believe your health system is on course to deliver safer AI. And it's quite interesting to see that we've got a mix of views here, actually. So some are unsure and some are saying yes, and then a few are saying no. And we'll take a temperature check towards the end as well to actually see how many people feel that we are on course or not on course to actually deliver this. That's interesting. So that's the total percentage of actually it's out of 10 who are actually on the webinar. So what we'll do at the end of this webinar as well is take the results from these different surveys that we're putting in place. But actually the audience is here for persuading. So that's going to be quite interesting. The majority of people are actually unsure on this. Okay, so I'm just going to give you a little bit of a detail around the people that are joining us today. So we've got Lawrence Freeman, who's head of data and next generation technology at Kubrick. And he's going to be joined by Dr. Kit Latham, who's co-founder and CEO at Credentially and a former A&E doctor. And they're going to be exploring some pretty interesting work around NLP. And then we've got John Hodinott, who's director and principal at Technology. He's going to be talking wider about AI and governance. And for those of you that don't know me, I'm Rachel Dunscombe, CEO of the NHS Digital Academy, and also worked in various guises with everyone else on the webinar today. So delighted to be joined by you, and thank you for being part of this event, which is providing thought leadership for the NHS and wider. Okay, so I am gonna now head across to the guys from Technology. So over to you, John. I think we will be driving the slides from here for you.
Thanks, Rachel. Are we not starting with Lawrence? I thought that was the...
Okay, yes. So shall we start with Lawrence? Is it going to be you first, Lawrence?
Yeah, excellent. I'm happy for that.
Brilliant. Okay, let's head over to your slides then.
Thank you. Right, I'm just sharing my screen and full screen that. Okay, can everyone see that okay? I assume so. Good. So thanks everyone for joining. The title of this, as Rachel described, a little look at natural language processing and AI and how this, our title is not just words, okay? It's not just words with natural language processing. It can actually save lives, hence the hashtag. So there's two real important outcomes that I would love us to be able to get off the back of this 20 minutes webinar section. So first of all, how technology can be an enabler for better individual patient healthcare. So particularly looking at how tech is an enabler. We do not want to use technology for tech's sake in anything that we do. We should always focus on what is the problem that we're trying to solve. And if technology happens to be part of that solution, then great. If not, then also great, because we're just all about solving problems. In the book by Jim Collins, Good to Great, which Kubrick Group focuses a lot on, it says that technology can be an accelerator to success, not the success in itself. So that's one thing that we're really looking at. And the other aspect of this webinar is the accessibility of really complex technology in the AI world. Particularly, we're looking at natural language processing, how this is commoditized, how it is so accessible now, whereas a number of years ago, not in the too distant past, that wasn't the same story. So let's keep those two parts in mind as we go through this next 20 minutes. So what is our problem statement? What are we trying to solve? Well, we all agree, I'm sure, that accurate and timely data being captured about patients, about individual patients, for the improvement of patient care is crucial. We all appreciate the importance of data for decision making and for handling this. However, in order to capture this accurate and timely data comes at the cost of something. It will come at the cost and the expense of a clinician to be able to record and log this critical information. And the problem is that clinicians, I'm sure would agree, would much rather spend their time with a patient. And we're going to see some statistics about the importance of this in a minute. So it's a catch-22. We have to record the data. The clinicians have to do this. They are the experts. But the more time they spend doing this, the less time they have available to spend with patients. So data entry you could describe as an administrative burden. Think of the scenarios that we'll again come to later on with Dr. Kit Latham when we do our demonstration. There might be a scenario where there are handover situations from one medical professional to another. In order to do a successful handover, there has to be accurate data. But in certain critical situations, there may not practically be the time to enter that data. And that is going to result in a lower quality handover. And when it does come to manual data entry in any domain, this is going to likely cause data duplication. And the more duplications you have of data, the higher risk of multiple versions of the truth or a lack of a single version of the truth, which will lead to its own problems. So here we have numerous problems, all boiling down to time. I wish we had more time. Okay, so this takes us to the next point, really. There's some excellent research that I'd recommend anyone to look into by Dr. Eric Topol. He specializes in individualized patient care, and he refers to the gift of time. So time is a gift, but particularly in this area, and how artificial intelligence is an enabler to get back more time, particularly in the remit we're talking about clinicians and patient care. So this, the outcome of this research is really liberation from keyboards or yellow slips, as clinicians may be more perhaps familiar with, so that you can then spend more time with patients. There's a relatively recent tweet that he put up that I just wanted to draw some attention to as well. Just looking at the bits I've highlighted, time is essential to the quality of care patients receive. And then looking at a research performed by the National Bureau of Economic Research down the bottom there, for every extra minute that a clinician spends with a patient in a visit, there is a reduction of a risk of readmission by 8%. So we can see statistically proven there is much value to be had in greater time spent between clinicians and patients. So where does this fit in with AI then? Well, I'm just going to spend maybe 3 minutes talking about 3 different areas of artificial intelligence that are going to then take us into our demonstration of natural language processing. So first, if we just mention the word neural networks, I'm sure we've all heard of this. It is nothing new. I don't know if we had time, I might ask for a Menti vote on when do you think neural networks were invented, the mathematics behind it. So have a number in your head. Are you anywhere near the 1940s? Perhaps that is surprising. Neural networks, the mathematics and the logic behind it were invented in the 1940s, and they largely did not change at all until now. What has changed then? So why do we now have the explosion of AI using this old technology? It's because of the prevalence now that we have of computational power. It's what cloud providers have given us. It's the ease of access that we have to endlessly scalable, scaling out, scaling up computer and computer power, because the design of neural networks was before its time, or maybe computational availability was after its time. But wherever, the two have coincided, and we now have an explosion of accessibility to AI. Now, a neural network, very briefly, is the connections between neurons and the synapses and the way information flows and causes pathways from one to the other. So what a deep learning, you may have heard of deep learning. Deep learning is a neural network which has at least 3 layers of information, each specializing on a different area, a different feature. So imagine we've got some X-rays there flowing in to a computer which is running a deep learning model. Images will come in. Perhaps the first layer specializes on recognizing edges of an image, like the edge of the cranium we can see there on the first picture, or the edge of anything, the edge physically of an object in a photo. The first layer is great at recognizing them. Maybe, so then the data flows through to the next layer. Maybe the second layer is expert at recognizing the midtones of an image. And perhaps the last layer is expert at recognizing specific parts of an image, like the eye socket of a cranium. Whatever the examples might be, the more layers you have, the deeper the model, and the more it's able to then have a new image come in. It will recognize, oh, I've seen that before. I've seen a label from one of the millions of examples I've been trained on. And it says, yep, I know exactly what that image is. So brief run over deep learning on image recognition. We can apply the same principle to text. So if we were to train a model with millions of examples of text flowing through, then a natural language processing model is able to look at the language, let's say English language, and the more examples and exposure it gets to natural language, which is how we would write our documents, the more the model will start recognizing, hey, there's some patterns here. I frequently see these two words frequently seem to appear next to each other, or within a distance of maybe 2 or 3 words from each other. And the more examples you feed into a model, the more it can recognize and get used to the grammar of the linguistics of a language. And by the time it then has millions of examples, it's now able to understand classification. So what is this document about? Hey, this is a document about a specific medical procedure, or this is a document about oil and gas, or whatever it might be. It can understand the sentiment of the language that's used, and it is able to extract entities that are referenced, again, specific things like locations or procedures or diagnoses that are in the text. Now, what is really amazing, I think, is the last slide I've got in this, deep transfer learning. With deep transfer learning, we take a model that's been trained, let's say, on language recognition, but we inject in some specific domain knowledge on a different model that's been trained on something like healthcare specifically, or on insurance, or on financial services. And we inject this one last layer that we've got there, and suddenly our model, it's a bit like Total Recall, the movie, or something, where we've suddenly got a brain injection and a mind intelligence raise artificially, and we can suddenly understand something new. So we're able to mix models together. And that is a great thing. However, remember on the first slide, I said there's a couple of things I'd love us to take away, and that is the ease of access and the commoditization of these kind of models. Now, unfortunately, for the majority of organizations, we do not have the time, the resources, the expertise, but also the example use cases of millions and millions of labeled documents or labeled images to be able to build our own models. It is out of our reach. And so what is really now exciting is things like AWS as a cloud provider, but other cloud providers will have similar. I'm going to focus on AWS. They have a service called Transcribe Medical and also AWS Comprehend. Now, what we've got on this slide is an example of some text, some free text that's coming in. But what is so incredible about Transcribe Medical is that, and Comprehend, is it can identify these three really key in the healthcare data sets. So we have the RX norm, which is able to identify, and it's trained on, so think of that transfer layer that's been fed in. It can recognize drugs by name, so pharmaceutical data. Not only that, and I won't actually attempt to pronounce that one that you can see there underlined in red, but not only that, it can also recognize dosage. So we've got 50 milligrams there, and it can recognize things like frequencies of dosage because it's trained to look for that in the model. We've got ICD-10, we've got SNOMED also built into AWS Transcribe Medical. So we've got tariff-based and clinician-based terminology for diagnoses. This is incredible, I think. So this takes us then to accessibility. You may have been on last week's webinar where Kubrick, we talked about the global skills emergency. Well, Kubrick are training our data consultants to be able to, just over 4 months, use this kind of technology. And we're about to demonstrate a product that was actually built by 2 of our consultants. One was straight out of training in the machine learning engineering, and another around 18 months experience after being trained in data engineering. So these guys have built a great product. Any live demonstration brings an element of nervousness, but anyone who's interested in the tech, you can see that we're using AWS Transcribe, AWS Comprehend, and Kafka to stream this data back down to my laptop. So I'm just going to change my screen share and introduce Dr. Kit Latham. I've been talking for a long time. Kit, would you mind describing, while I get this working, just the scenario? Give us a couple of minutes. I'm going to run this product. Yeah.
Hi, everyone. So the scenario that we are about to see a demonstration on is very common. A patient has been seen by a paramedic and needs to transfer the information that they've gathered based on the history they were given by a 999 call handler, the examination and investigations that they've been able to do on the patient at the scene, then to make an assessment as to where this patient needs to be triaged, and then to hand over to the coordinator typically of that department to ensure that the patient is suitable for the place that they're going to be taken to. So in the scenario that we are about to engage in, the patient has been seen by a paramedic following a 999 call, and the paramedic is now relating their assessment to the coordinator of a local hyperacute stroke unit.
Thanks. Okay, so I will hit go, and after a couple of seconds, you want to go ahead and begin. Okay. Yeah, over to you.
Hi there. Hi, this is Dr. Kit Latham with the Yorkshire Ambulance Service. I'd like to discuss a patient, please, for possible admission to HAZU. This is a 78-year-old man who presented at 6:20 p.m. this evening with a history of new right-sided facial weakness and speech disturbance. There was no loss of consciousness. There was no seizure activity. He has a Rosier score of 2. The patient's past medical history is hypertension and atrial fibrillation. The patient is currently taking warfarin, ramipril, and doxycycline. On examination, the patient has a right-sided facial weakness and slurred speech. His BM is 5, blood pressure is 158/95. ECG shows atrial fibrillation. I think that this is a suitable candidate for the hyperacute stroke unit, and will be grateful if you could admit this patient for further management.
Thanks very much, Kit. So it's not perfect. In fact, I will hit stop, but it's not perfect on the general language, but you can see as soon as it recognizes some medical terminology there, it's been able to live identify the ICD-10 codes. So if and rank them by probability based on the overall occurrence of that, that diagnosis that was mentioned. So here, top of the ranking order, we've got R29.810, which if I mouse over here, shows you the ICD-10 code, facial weakness, and other. So this is just a proof of concept. It's just to really show the strength of NLP using AWS technology, and it is highly available. The costing of it is publicly available, obviously, and it does amount to, I can roughly give you the cost according to AWS. It is, if you were to pass through 250,000 minutes worth of transcribing over a 1 month period, then the cost is about £6,000 for that. So it's $0.02 per minute. Now everything has a cost, but if we compare the cost of giving back to time to the clinicians, which ultimately results in better patient care, which also ultimately results in reduced readmission rates, then there's a very quantifiable value that we can assign to that. And that concludes, thank you very much, Kit. And that concludes our demonstration.
Wonderful. Thank you so much for that. And I think this is incredibly compelling. Just today, I was talking to one trust who are starting to use this to summarize letters and other parts of the clinical record that they've got in a non-structured form. Now, we've got one question in that I am going to ask now, and I'm going to ask you this, Lawrence, because I know you've worked in other sectors. You've worked across multiple sectors. The question is from Pardeep, and it's, is transfer learning like putting deep learning model with other deep learning model? Could you use the models from completely unrelated sector, e.g. finance and healthcare? And I'm quite interested about that transferability across sectors. So I don't know if you can just give us a quick answer on that one, Lawrence.
The real value of transfer learning, that you can take a layer from any other, well, from any other pre-trained model and attach it to your base model to extend it with that extra functionality, that extra knowledge, if you like, which is why I like to think of it as a bit like the Total Recall movie. You know, you are implanting extra knowledge artificially into a model. Brilliant.
Fantastic. And I have seen models successfully used, say, in public health from Facebook, some of the algorithms they use. So I do know that they can be transferable, but actually Lawrence is the absolute expert on this, not me. Right. Okay. So I am going to hand over now to John. And John, I know that you're going to take over now in terms of giving us a little bit of background, but you're going to start with a question, aren't you?
I am. Thank you, Rachel, and thanks to Kit and Lawrence. That was a really interesting demonstration there. So just want to slightly flip the conversation now, and as you'll see up on the wall, on the screen, sorry, we've got a word cloud developing. So really just interested in your thoughts around how we move from, you know, fascinating proofs of concept, and you know, we've just seen one there that the team at Kubrick, with relatively little training, have been able to put together in very short order. And, you know, okay, it's a live demo, things are never quite as slick as Total Recall. But I mean, I think, you know, if you hadn't seen some of these things in the past, it's quite impressive how quickly you can develop working solutions. But that's a long way away from having that operating in a busy A&E department with a paramedic speaking to you from an ambulance. And being able to have trust in that solution right across the organization, from, you know, from the boardroom right to the bedside. So if you've got any thoughts about what's going to be required to get us to that point of having not just one AI product, but a range of AI solutions in the organization at scale, just interested in your thoughts. And you can see already people are typing away. So infrastructure is coming up very high. As is data investment, I guess, would be an obvious one. Collaboration, but I'm seeing some other things in here that are quite handy, given what I'm hoping to talk about in a moment. Areas such as synthetic data, data governance, culture shift, and so on, and explainability, another good one. So look, I think people are very much along the right lines here. And what I want to talk about now for the next 20 minutes is not so much the technology. I think we can all agree that the technology is amazing and offers a huge opportunities. But where do you start? Where do you go as an organization in terms of deploying this at scale? And of course, in healthcare, we're focused particularly on doing that safely and keeping patient safety at the forefront. So next slide, please. Okay, so we want to talk on three broad areas, and the first here is around that capability. And we've just seen that AI solutions can be developed. But as a healthcare organization, or frankly any organization, where do you start if you're not already an expert in this? At Technology, we've been doing quite a lot of work over the past couple of years with healthcare providers, both in the NHS and globally, looking at this question. And we see kind of 5 broad areas that I'll just touch on. The first is it's absolutely critical that as an organization, you need to have enough skills to be an intelligent user. It's amazing to see these demonstrations, but what we don't want is healthcare providers or hospitals being driven by the technology, having very impressive salespeople turning up to sell us on a solution that's neither fit for purpose, nor scalable, nor appropriate for your organization. So having enough of an understanding of the art of the possible to understand where AI can be deployed in your organization is key. But also the level of knowledge to hold those providers, if you're buying things in from externally, to hold those providers to account. What we can't have is these AI solutions in the organization and not holding the people behind them to account. Second is, deep AI expertise. And we've just seen, development of an NLP model. Each area of AI comes with its own level of complexity. And it's important, if you're going to build one of these models, to have that. But there's no possible way, certainly in the NHS or any healthcare providers I've seen, to build that internally right across the range of solutions that you're likely to have. So the question here is really one of, what are you going to build internally and create expertise in? Where will you buy in expertise? And we were just seeing something with an AWS component. So clearly componentry can be brought in. And where might you look to build that expertise by expanding existing staff? Sorry, the last example is around partnering with other providers. So we're seeing a lot in healthcare where organizations are coming together across 2 axes. One is with other healthcare organizations, so in the NHS, potentially with other trusts. But we're also seeing organizations where they're looking to partner more on a geographic basis. So getting together either with local authorities or businesses who are operating in their area and trying to pool expertise to build that capability. Now, the third one is probably no surprise, clinical operational domain expertise. This is something that every healthcare organization can absolutely bring to bear. But what I think is really critical is that expertise from the front line. And we just saw, Kit standing in as doing a great turn as a paramedic. What's really important is that you're bringing in that frontline expertise. Now, healthcare providers do have that, but doing that in a coordinated way so that you're getting the right expertise from the business is absolutely critical. Now, organizational AI awareness, what do we mean by that? Well, just imagine yourself in a hospital or healthcare setting where that AI tool we just saw being demonstrated has been deployed. As with any new technology, there's a level of understanding about what it can do, but almost as importantly, what it can't do that's required. And as we start to scale up and we're deploying a range of AI solutions, it's critical we don't end up in the the early days of using route finding software where people will find themselves driving into fields and getting stuck in the mud because the sat nav told me to. We can't be having a situation where AI is allowed to run rampant and patients are diagnosed with something completely inappropriate because the technology told me. So it's really critical the workforce is brought along on that journey, that they understand the tools and that they know where to step in. And lastly, program delivery. I think this is something that most organizations now will have to at least some level. But I think in the context of AI, we saw a demonstration of what can be done in a short time frame. You very much need to be thinking about moving towards an agile methodology in that space. Next slide, please. So another quick question. if you can, please, can you think about of those 5 areas, ranking those? So I've talked them through in the order we've got on the screen at the moment. I don't for a minute think that's the order of importance. So if you can rank it in terms of the level of importance you see for your organization, I think that would be really interesting. And we can then maybe, as we get to the end, talk about that. Now, just need to be doing that on Menti. Here we go. So, okay, so clinical operational expertise. Yeah, I mean, and the good news is that's one thing the organization does have, but it's unlocking that and knowing how to deploy it. Organizational awareness, okay, that's also really critical. I think the scale of that engagement across the business, and recognizing that, you know, staff aren't always there at lunchtime to go to a training session. We need to be thinking about staff on night shift as well. Okay, that's really good. Next slide. Okay, moving on to another area now. We were talking, Lawrence there was talking a lot about the data that sits behind this. You know, I think anyone working in healthcare will recognize the challenge around data. So thinking about healthcare data, there is a huge amount of information in the business, and no one would be surprised to know the number of systems that healthcare organizations have. But the challenge is the level of siloed nature to that data. The fact that today a lot of that data is not appropriately codified, and there are problems around data quality. In terms of moving forward then, one of the challenges, and even if we just take that example we had of using neural language processing, having access to and unlocking all of the data sets that you might want to have access to in your organization, patient records and other systems, starts to give us some real problems. As anyone who's worked in any length of time in innovation in healthcare will know, getting ethics approval, getting through the regulatory and legal hoops to start linking data sets, to start giving access to any of that data externally is a very complex area, and that's not going to change overnight. From our perspective at Technology, we see it's absolutely critical to start moving away potentially from some of the large monolithic platforms towards a model of open data, and the open EHR standard being an important one in that regard, but also to making sure that there is improved clinical coding of data sets so that those tools such as NLP can be applied. For those interested in looking at this in more detail, you know, moving towards more of a data mesh model has a lot of opportunity for healthcare, and looking at designing data structures in a way that it has you know, not so much a centralized platform, but that distributed set of effectively data products that are domain specific, but build a model where you can actually have a level of self-service and analytics across the organization. Now, if you joined us last week, you will have heard Joshua Simmons from Genomics England talk about their own journey in that regard, and how they've used those principles of data mesh to really start thinking about how they develop a sort of omics to product right through the business. Now, one last point on this slide is that's great. It's great having the ability to develop that long-term data thinking, but that doesn't help in the short term. You know, how do you unlock potential value in the sort of models we just saw the team from Kubrick doing? You know, and we did that with you know, just publicly available data, but how do you do that in an organizational context? And one of the areas that we've been doing a lot of work with, in our case specifically with DivePlane, is around synthetic data. So having the opportunity to actually create completely realistic but non-patient related data gives you a real opportunity to do that. So you can create either at a cohort or at a population level data that is simply not possible to link back to the original patient records, but which give you a richness of data that you can then build AI solutions on top of without having to deal with some of the ethics and regulatory challenges. Next slide, please. So just a really quick question here. So, you know, in your organization, do you think that there's an opportunity to drive innovation by creating synthetic data sets and giving access more broadly across the business to have a play effectively, and doing away with some of the challenges associated with ethics approval? So, general trend, perhaps unsurprisingly, is towards trying to find ways to unlock value in data. I'm not surprised that no one's saying that there are no barriers to data sharing in your organization. That would be a first. Okay, let's move on to the last of my 3 slides. Okay, so one of the last points, or the last major area I want to cover, but there are a few points to it, is around the governance of AI once it's in the organization. So, you know, I touched briefly on the question of, well, you know, what happens if an AI solution were to run rampant and we were metaphorically stuck in a field because the sat-nav told us? Well, you know, it's easy enough to find that amusing in this context, but the reality is, you know, there would be a myriad ways in which an AI solution could be slightly off. And in the, you know, the busy world of healthcare, people don't take the time to stop and challenge that. So how can you, as an organization, have the confidence to release an AI solution into live and know that you're not going to be increasing the risk of harm to patients? And there's 6 points I want to touch on. And really, the first point here is to recognize that, you know, this is not a new problem for healthcare. If I were to think about how, as an organization, you release a new clinician, be that a nurse or a doctor, who's only just left their training into the business, there would be no question here around giving them a great license to cause harm. The organization already has in place a whole range of oversight mechanisms to support and control what that human resource is doing. So what we need to think about as an organization is how we now start to apply some of that thinking to these artificial resources. And really, you know, it's the same supervisory and audit activity that you would be applying. So if we think first about clinical safety, so organizations will already have clinical safety tools in terms of reporting on the activities and performance of doctors and nurses and other clinicians. And what's important is about creating the same feedback cycles so that we know, you know, where an AI may have faltered or may have misinterpreted something, and to have the processes and the feedback loops in place to understand where that improvement is needed. Now, the second point is bias detection. And I think, you know, in the media, quite rightly, there's been, you know, a great deal of focus on the potential for, I mean, obviously we wouldn't want intentional, but even as importantly, unintentional bias in AI tools. And, you know, even just as you move around the UK, for example, if you were to have trained an AI solution, it would be very easy to introduce quite minor but critical biases based on local demographics. If you were to feed it information on the age profile, the gender profile, the ethnic profile, other factors, that might not be the same if we were deploying a solution for the Highlands and Islands, as it might be in central London or Birmingham or anywhere else in the country. So it's important to make sure that as healthcare organizations, we have access to the data set. That means we can train the models broadly enough to ensure that we're not introducing bias into it. So that's something I think a really important area. Now, having said that, there are areas in which you might want to have a level of bias. So if you think for a moment around pediatrics, clearly what you're looking for in the context of engaging with young people may be a different outcome and a different output from adults. So it's perfectly appropriate that you're going to segment some of your patient cohorts and be applying different algorithms in order to make sure that you're doing something that's appropriate for that group, but not introducing unnecessary bias into the broader population. And leading on from that is around new demographics. With clinicians and with anyone in a working environment, what you were taught and what you understood about your field, in my case, 20, 30 years ago, when I was starting out, is not the same today. And so ongoing professional development is absolutely the norm in all organizations. So how do you make sure that with an AI solution that even things as simple as demographic changes, are you feeding in that information around changes from immigration, an extension of services, or any other change in the environment that's being fed into the training that the model has been given over time, so that there is not a drift, an introduction effectively of some element of bias. So AI, just like our human colleagues, require a level of ongoing training to be effective. The fourth point, explainable unblackboxing. I think we technology may have coined that phrase, I'm not sure, but I'm sure you're all familiar with the idea of a black box solution. This is one which gives a great output, hopefully, but we have no idea what's going on under the hood. And it's really important in the context of AI that we are able to do some element of stripping away that black box. In any context where there had been a significant failure of the system as a whole, it would be critical to make sure that we understood how the AI may have played a part or contributed in that way, so that you're able to speak to the board, to staff, to patients and their families in a way they can understand, to say this is what happened in this situation that may have led to a bad outcome, and to understand where in the system anything did or did not go wrong, and where there may be situations where there was unfortunately an element of bad luck. As long as we've got a black box in the middle of our solution, inevitably and politically, it will be the black box that gets the blame, even in situations where it's not entirely fair. Clinical audit, well, again, there's a very well-established process in healthcare for this, but making sure that's been expanded and there's an audit capability across the algorithms that you have in the organization is critical. Now, in fact, one of the areas that AI potentially has an edge here is that because of the way that they're designed, it's very easy to build in that audit from day one. We saw on the screen earlier the system recording what it was hearing, what decisions it was making in a way that would be very easy to have an audit trail for. And potentially that way, it means that the AI solutions can expose a great deal more of their behavior and performance to audit than we currently manage to achieve with the human part of the equation. But it's critical that those processes are applied consistently across the business, and that's brought to bear. Now, lastly, pathway performance. What we're not here talking about is about replacing humans in every case, or even mainly, but we need to think about how that decision support is provided. So where we've got a human, and we saw Kit there as a paramedic, we talked about freeing up that time. So if we're able to capture a relatively conversational exchange of patient information and prevent staff having to repeat that by going into the system, typing it up, finding ICD-10 codes, etc., then that's great. That frees up the human, but we're not taking the human out of the process at that point. We're just trying to improve the use of their time. And so it's about thinking, well, it's all well and good having one AI solution, but how do we make sure that pathway as a whole is improved? That we're freeing up the human resources to focus on areas that at this point we absolutely don't have a technology solution for, and importantly, where we would never want to have technology replacing the human in the process. Okay, that's a pretty quick jog through those. Next slide, please. I think we've got another question. Okay, so interested in your thoughts, and this might then feed into the Q&A in the next few minutes, but and the discussion. But where do you see your organization in terms of governance? How do you think you will be going about creating those governance procedures and structures that will support greater industrialized use of AI in the future? Again, that's in Menti if you have the opportunity to add anything. Okay, yeah, I mean, exactly. So mainstream governance, I think that's really the key message there is, maybe at times it's frustrating in healthcare, some of the governance processes that exist, but I think as with many other regulated industries, the governance is there for a purpose. And I think it's about trying to make sure that we don't create a whole new set of processes, but making sure that we're building it into what's already there. Best practice from other industries, absolutely. Specialist medical ethicists, absolutely. Patient advocates, I think, is a really good point. Some of the work we've been doing in the AI space has absolutely involved getting input and engagement from patient advocates. It's been really interesting to hear their perspective on some of this. Yeah, the colleges, the professional bodies, nice, and so on. Okay, what that training workforce, teaching in med school, absolutely. I think, yeah, reaching back down into the educational process is going to be critical to some of this. But I think also recognizing that, the work, if we wait for the workforce to turn over while everyone's had a chance to hear about it as part of their early career training, is slightly kicking the can down the road. So we absolutely need to be doing that so that people coming in are better than the rest of us, but we're going to need to think about the existing workforce as well. Leadership, yep, no, I would agree. Now, Rachel, we may want to flip this into the ongoing discussion because I'm seeing some good points come through here.
Idea. Yes, no, there's some great discussion points coming through here. And just to remind people, because I don't think everyone can see it at the moment, the Menti code for this is 66134622. So just any further on here. But thank you for that, John. I mean, that's kind of the whistle-stop tour of the North Star of governance for AI, which I think we're going to need to get us to scale and pace, aren't we? So really nice to see that people are sort of considering how we can do that and putting some thought into it. Good. So I am now going to take us to another Menti in a second. Just a reminder again of the hashtag Data Saves Lives. If you do look out at that, it's being used by Health Data Research UK, by a lot of the NHS, by the European Union now. I would encourage you to use this hashtag whenever you think about, data saving lives. Just a little bit of information about why this is really important to me. So this was the hashtag we used for work to do improvements around stroke, delirium, dementia, kidney care, and actually prove that as we use data, as you saw with Lawrence, to actually take codified data and risk stratify people and provide efficiencies and effectiveness in pathways, making their sort of time to needle or time to treatment faster. Based on that, we were improving lives and saving lives. So it's something that's really taken off. Originally came from Manchester University. It's now being used right across Europe. Thanks to Deepak, who's the professor that's taken it over to Europe. And I think there's quite a movement behind it. That is a copy of my lovely little purple badge that I used to wear around Data Saves Lives. But I think there is really an impetus in healthcare systems to actually use data to save lives and improve lives. And AI is part of that journey. One thing I like to remind people about is the NHS constitution that says that we'll work at the frontiers of science with the highest human skills. And that involves, treading the tightrope of using data effectively and advanced technologies as they emerge, like AI and so on. So I'm going to take you back to Menti now, and this time we have got the code up. Just really interested to know if you believe that the healthcare system in which you work really is on course to deliver AI safely and leverage it safely and has the tools and skills to do that. So just appreciate your feedback on that. I certainly know that through my work with the AI Council in the UK, we sort of look very much at governance, and great feedback earlier about other industries, because I've got to give a huge plug to military and nuclear industry, which are both high reliability industries. And they have, enabled me to actually draw from some of their governance to put into healthcare. So still unsure. And I think that, caution is good. No is the second most common option, and yes is third. So I still think we've got a journey to go on, and that's really good to get that feedback from everyone on the call. So thank you for that. Right, bear with me 1 second. So just going to go on to another Menti question now. And that question again with 66134622. How ready do you think your data is to enable life-saving AI? So for those of you that are in healthcare systems, do you think the data is ready in your organization or system to actually enable life-saving AI? And for some healthcare systems, they're still on paper. Some of that data is not a great quality. Some places are getting mostly towards clean codified real-time data. So those that certainly in the UK are in integrated care, sort of local record exemplars. And then I doubt anyone's going to say 100% ready. That's the panacea, but just good to check in. Good. So poor quality still, and I think that's representative of most healthcare systems. The data has not been collected for this use, and that's a very interesting piece, because what we're going to see in the coming years is that data is going to become a capital asset as we start to collect it for risk stratification and for longitudinal records. So it will go from being almost disposable in letters and something that maybe used once or twice to having multiple uses throughout somebody's life. And then we've got people that are saying much of it is still on paper. So that's interesting to see. Any more votes at all on 66134622? Because as we move towards, these coming technologies, we're going to have to use things like NLP to actually, clean the data and codify it and make it fit for purpose, and also create clean data in real time. And as Lawrence and Kit showed us earlier, that's going to be about using very innovative interfaces that don't take the doctor's sort of attention and the nurse's attention inappropriately away. So it's great to see we've got somebody there that's got mostly clean real-time data that supports some use cases. So I was very privileged to be at Salford, where we were more in that camp than in the other camps. So good to see that we've got somebody on the WebEx joining us who's in that area. Good. So final question from me. This is really, about building confidence for each of us. I sit on the AI Council for the UK government, and I don't know the half of it in any way. None of us do. This is still a field where we're all learning. So I'd like to know from you all really what you would like to learn more about in order to build confidence, because we all need to learn together in order to build confidence together and take the system through this journey of actually leveraging these tools to improve lives and save lives. So really keen. Again, the Menti code is 66134622. And while you're actually putting that in as well, I'd welcome any Q&A, any questions that you've got for John, Lawrence and Kit, because we're going to have probably around about 10 minutes towards the end for questions. This is good. Future regulatory sort of barriers. So we've got EU regs, and that's interesting because the EU are looking at how they bolster that with a duty of care, governance, data ethics. Ethics is a big one. Life cycle steps. Yes, there are no best practices at this point. Workforce development. I think that's really important. Legal frameworks. Yeah, so we've got some really good feedback here. And what we're going to do is actually gather these together and play them back to you as part of the feedback from this webinar. So examples of success, I think that's important. Knowing the data is gathered from studies. Yeah. How to safely synthesize data. So how do you create synthetic data? That's a piece that I've actually done some research in with Imperial College, but it's very early days. Lovely. So what we'll do, thank you so much for your feedback on this. We will take all of these and we'll play them back to you as part of the feedback from the webinar, along with any observations that we've got as a group around what we are actually seeing. Fantastic. Good. So I'm just going to leave this open and we're going to go back to the Q&A. I've had a couple of questions through actually via Twitter. And what I would like to do is ask John, Lawrence and Kit around some of the observations actually on education. We've had a number of sort of questions through about education. I'm going to ask Kit, first of all, as a doctor, what do you think is going to be important around these advanced technologies, both as a CEO that uses them, but also as a doctor? What do you think needs to be put into medical education going forward around AI, machine learning, RPA, and all of these advanced technologies? What do you think is going to be useful for the coming sort of generation of doctors?
I think medicine's already quite good at allowing for student-selected components and facilitating students that are interested in sort of the many disparate areas of medicine to engage in either project work or study of them. And so I think, I imagine it's happening already, but perhaps close links with the university's computer science departments and sort of a deliberate focus on student selected components that would allow those that are interested. And I think it's perhaps better if these people self-select. I certainly would have been very interested in this when I was at medical school, but it just wasn't sort of something that was offered. Would be a good way to get people that perhaps have a background in technology or interested in coding, programming, data science to have exposure, to build the connections and meet people that they can then work and partner with to build out either a student project using some of these tools. And I think Lawrence showed quite clearly that there's off-the-shelf technology now that's very powerful, very cheap, that can be pointed towards real areas of clinical need that then can be form a part of that person's medical training. So I think using the student selected components element of most medical curriculums is sort of something that jumps out to me as obvious, and also I'm sure it's happening already, but I created a group called the Doctors Digital Collective to allow not just doctors but any sort of health practitioner that was interested in tech, AI, data to kind of congregate, meet up, work together on hacky projects that they were interested in. And I think universities are a really good mixing pot for people like that, to allow them to get together and also to make sure that they've got the resources. I think we sadly lose a lot of our talent in tech in this country, in healthcare, because it can be so difficult to commercialize a new health tech innovation in our current kind of commercial landscape within the NHS. And so I think through universities giving people access to grant funding, so we were very fortunate at UCL, we had access to the Bright Ideas Award. We were able to win a grant for our first prototype that used machine learning to try and automate some of the paperwork that clinicians were having to doing around appraisal and revalidation. And so ensuring that students are aware of those funding sources and can access both the talent that they might need from maybe computer science departments and institutional backing and funding for projects that seem like they might be worth exploring more.
Wonderful. And that's very rich. And I think that community exploration is very, very important. And certainly from my experience with the Academy, that's allowed people as a group to explore the subject matter, which I think they felt a lot safer in doing. Lawrence, you've done a lot of work in actually bringing people from other careers into this sort of space. And I'm really interested because obviously we do have a skills emergency. We've talked about that before. I'm really interested in what's your sort of take in how we bring the skills in to support clinicians to make this journey towards embracing these technologies to save lives and improve lives.
Yeah, so education is obviously at the heart of what Kubrick Group's all about. That is what we do. We educate, we look at the skills emergency, but to to answer really the broader problem, I think it's so important that things like AI, it's not just for a certain privileged few. It's really important that the opportunity to learn technology, whether it be AI or other next gen technologies like this, is open to everyone, regardless of background. So that then may shift the problem to not only how accessible is the education, but how accessible is the hardware or the compute power that is available. And cloud providers are and can play a massive part in making, say, the cost accessible. So check out GCP, look at Azure, look at AWS. They pretty much all provide, say, the first 12 months with either zero cost or very low cost for that purpose. And it sometimes seems like a very steep learning curve to be able to get in, and it just seems so inaccessible. But by using these technologies, by getting started, by learning, say, Python, you'll then be able to, gradually get in and realize that it's not such an out of reach technology that you first might think.
So don't fear it. I like that. That's fantastic. And John, I know you've been doing work with healthcare systems around AI, and you're a sort of scholar of AI as well yourself. What are you seeing with those organisations that are making headway with this subject matter on the ground? Because I know you've worked with both the NHS and Australian system.
Yeah, and I think just picking up on what Kit said is really important, because I think there is a lot that is starting to happen now and on the ground, particularly in the university space, with medical schools, with computer science departments, around building that groundswell of excitement around what the technology can do. But certainly over the last few years, there has been a real barrier, I think, in a lot of organizations with those junior resources coming in, very passionate with new ideas. And I guess, so often the case, young people facing a whole range of barriers in their careers. But I think in the technology space, it's particularly obvious. If you look elsewhere, just obvious. So if you look at the creation of Facebook and others, there's no way that you'd have created the Facebook of healthcare with a couple of students taking over the industry. Now, there's probably some positives in that. We don't want healthcare systems completely upended. But unfortunately, I think at the moment, or historically, there's been so much constraint on innovation and what people who've got a different perspective and a different idea are able to do. And as Kit was saying, the most obvious area is around access to funding. But I think it's also a mindset in organizations, and where I've seen organizations really turn this around is where leadership have really started to engage generally with junior staff who are coming in with these new ideas, but right across the business. If you're able to unlock that potential, that latent potential in the existing business, then that's a kind of perfect storm. It's all well and good getting in the Amazons or the Googles, the Facebooks to come and sell you a solution. But how much better if you're able to unlock that creativity and that domain knowledge in the business, coupled with just enough understanding to be dangerous of the technology. Because once you've been able to get that use case together, whether it be an NLP model and so on, it's very easy to wrap around yourself the technical capability. And of course, the great thing in healthcare is that everyone agrees that this is an area we need to be investing in. Compared to a lot of other industries, very easy to find people who are prepared to give their time, be it a hackathon, whatever, to contribute and help get things moving. So I think there's real opportunity for health to expand on this. And what we're then perhaps doing with the university space is to make sure that there's a nice, easy path into healthcare organizations for junior staff, but really right across the stack.
Wonderful. So building that intelligent client and the confidence to be able to leverage it. Fantastic. Well, thank you, John. Thank you, Lawrence. Thank you, Kit. And thank you everyone else for joining us. We will be, we've recorded this webinar. We will be making it available in the next week or two. Just to encourage everyone on the call to remember that, hashtag data saves lives. I think it's going to have increasing applicability over the coming years. And thank you from the Technology Group and Kubrick Group as well for being with us. Look forward to talking to you on future WebExes. Thank you and have a good evening.